Do androids dream of electric sheep? Philip K. Dick asked the question in the title of his 1968 novel. For engineering, the useful question is more precise. Can a machine stop external action, replay an experience, reorganize what it learned, and change what it does next? MDOS Cortex begins from that question. Not biological dreaming, but verified experience becoming a better future method. Before we speak about artificial intelligence, look at the human brain. The red region is the prefrontal cortex. It lies at the front of the frontal lobes behind the forehead. It does not contain the whole mind, and it does not command the brain like a tiny chief. It participates in a distributed control system. Its useful executive roles include keeping a goal active, selecting relevant information, updating working context, inhibiting an unsuitable response, changing strategy, and monitoring whether an action produced the expected result. Here is the biological idea in one loop. Vision, hearing, touch, and signals from the body describe the present situation. Goals and prior experience give that situation a direction. Prefrontal control helps select a response, delays or blocks competing responses, and sends the selected route toward motor systems. The world then changes. The senses observe the result, and the result can correct the next decision. The important point is not a single brain area. It is the closed loop from perception, through controlled action, back to observed consequence. Why compare this with an operating system? A computer operating system does not write every document or perform every calculation. It coordinates processes, resources, permissions, input, output, interruption, and error states so that programs can work together. In a limited functional analogy, prefrontal control performs comparable executive coordination for behavior. The analogy is useful, but it is not biological identity. A cortex is not literally a digital kernel, and human executive control is distributed across many interacting neural systems. A robot or software agent needs an explicit version of that control. Cameras, microphones, touch sensors, files, and APIs provide observations. A reasoning model proposes meaning and possible actions. A control layer keeps the goal, selects context, checks policy and permission, chooses an available capability, permits or inhibits the action, records what actually happened, and asks an independent verifier whether the goal was reached. MDOS calls this layer the Artificial Prefrontal Cortex. From this point on, the short name a PFC means exactly that, the agent's inspectable executive control plane. Before memory and replay, one condition is essential. The robot must observe the consequence of its own action. The camera is not decoration. It is the visual sensor that closes the loop. The artificial prefrontal cortex issues a bounded motor command, compares the expected movement with the live image, and then continues, corrects, or inhibits the next pulse. Without sensory readback, a command is only an intention. With it, action becomes monitored evidence. Now we can define MDOS. MD means Markdown. A Markdown file is an ordinary plain-text file whose name ends in .md. Simple marks create headings, lists, code blocks, and links. A person can open it with any text editor. A model can read it directly. A file such as goal_lift_tail.md can state the goal, the safety limits, the expected visual effect, and links to the permitted action and verifier. Markdown is not magic. Its value is that operating knowledge becomes readable, editable, linkable, and auditable. Markdown is only one layer. JSON files hold rigid machine-readable structures, task fields, schemas, permissions, connector definitions, relations, and current state. ND-JSON stores one JSON event per line, so observations, action receipts, and verdicts form a chronological stream. Registered executors perform the physical or digital work. They may be Python, JavaScript, or Node, shell scripts, C++ programs, PHP, or any bounded executable with a declared contract. Sensors and APIs enter through connectors. Builders reconstruct indexes. Verifiers compare the requested result with the observed result. Together, these files form a capillary semantic and operational network. Some links mean explains or defines. Other links mean requires, authorizes, executes, observes, produces, verifies, corrects, or replays. That difference is essential. MDOS is not a pile of notes and not merely a picture in Obsidian. Obsidian can make the Markdown graph visible, but the operating force comes from binding meaning to executable routes, permission gates, state transitions, evidence, and deterministic readback. Operational context is the file system. This is where MDOS inherits the philosophy of UNIX. UNIX made complex systems from small programs that did one job and exchanged explicit streams. MDOS makes complex agency from small bounded agentic processes that do one job and exchange typed, verified artifacts. The natural language command surface plays the role of a shell. The agentic kernel compiles tasks and manages process state, capabilities, tools, budgets, permissions, execution, and verification. A verified artifact replaces a pipe. Verified, failed, blocked, and uncertain replace vague claims of completion. MDOS orchestrates agentic processes as UNIX orchestrated machine processes, at a different layer. In the current verified host path, Codex is the execution layer. Codex is OpenAI's open-source coding agent command line project, published on GitHub. It reads the operating files, reasons about the task, edits artifacts, invokes bounded tools, and reads the result back. MDOS is the persistent method and identity stored in the file system. This is the meaning of MDOS Cortex in this demonstration. Codex plus MDOS. The central model supplies flexible reasoning. The surrounding artificial prefrontal cortex graph supplies goals, context, policy, action routes, memory, evidence, and correction across sessions. The original MDOS diagram now has a precise reading. The model core is in the center. Around it is a dynamic network of Markdown pages, structured state, sensors, connectors, tasks, policies, snapshots, and semantic actions. The modern name for the operational projection is the Artificial Prefrontal Cortex graph. It is directed because an action produces an outcome. It is temporal because the action occurs before the observation. It is typed because a goal is not an action, and an action receipt is not proof of success. Every important edge must preserve provenance and verification status. Consider one concrete process. Lift the furry tail on the table. A Markdown page explains the goal and safety boundary. A JSON task states the initial condition and the visual acceptance test. The policy allows only bounded arm pulses. A connector maps the symbolic action to the registered motor executor. The executor moves the arm. The camera records the result. An action receipt records what command ran. The verifier asks a separate question. Did the tail actually leave the table? Only the observed physical effect can close that claim. Now watch the decisive event continuously. The tail begins on the table. The gripper engages it. The arm raises it clear of the surface, keeps it visibly elevated, and then lowers it. This is more than a motor command and more than a confident sentence saying done. It is an observed state change. The event becomes admissible learning evidence only when the video observation, task condition, action receipt, expected effect, actual effect, and verifier result are bound into one episode. Replay is how an episode can change future method. The system reactivates the sequence. Initial state, selected action, tail rises, verification succeeds. It also replays failures and safety conflicts. During this offline phase, external actuators are disabled. Competing explanations can be compared, a corrected procedure can be distilled, and the candidate must pass new tests and no regression checks before promotion. Calling this robotic REM is an engineering metaphor. Biological memory consolidation uses distributed hippocampal and cortical interactions and more than one sleep stage. Prefrontal activity participates, but does not perform consolidation alone. MDOS version 5 already consolidates verified episodes into its external graph, skills, indexes, and future context selection. Changing the foundation model's weights is a separate proposed stage. A future offline pipeline could train an adapter or update model weights from selected episodes, then require sealed evaluations before installation. If a familiar skill becomes reliable inside the model, deliberative a PFC intervention may fall for that route. Identity, permission, anomaly detection, evidence, and hard safety gates must remain active. Reduced deliberation is not reduced safety. The psychologist who named the flow experience is the man whose name appears on screen. Pronounced approximately, me high, cheek sent me high e. Flow is deep absorption in a task whose challenge and skill are well matched. Transient hypofrontality is a later hypothesis. Some explicit self-monitoring and analytic control may temporarily decrease during fluent performance. It does not mean that the entire prefrontal cortex switches off. For MDOS, this suggests a testable engineering rule. Use strong executive control while a route is novel, then reduce repeated deliberation after verified consolidation, while permanent policy and safety control remain. The complete definition is now simple. MDOS is a Markdown native agentic operating file system. Its agentic kernel and artificial prefrontal cortex orchestrate small processes of perception, reasoning, action, verification, memory, and replay. Markdown carries human-readable method and links. JSON carries contracts and state. NDJSON carries event history. Executors act. Connectors bind external systems. Sensors observe. Verifiers decide what the evidence supports. The graph preserves what was learned and filters future action. It is not another tool-calling chat wrapper. It is a method for turning capable reasoning into bounded, cumulative, and inspectable agency. Here is the comparison that matters. An LLM alone can reach a very high peak. It may solve a difficult problem with extraordinary quality. But when the successful route, its conditions, its failures, and its checks disappear with the session, the next attempt begins near the old baseline. The peak was real. What is missing is carryover. These are brilliant bursts separated by resets. Now keep the same model and add MDOS. The model still creates the leap. MDOS frames the goal, records the episode, verifies the observed result, rejects failed routes, and preserves the route that passes its gates. The next attempt starts from verified progress instead of from zero. Its new burst can therefore exceed the model's earlier maximum. MDOS does not replace the model's intelligence. It makes that intelligence persistent, correctable, reusable, and cumulative. The fair comparison is the LLM alone against the same LLM governed by method. Model performance plus MDOS method produces verified consolidation. Consolidated routes become reliable skill. As a verified skill becomes familiar, repeated deliberation can decrease and performance can become fluent. That is the engineering path toward flow. The executive controller does not disappear. Identity, policy, anomaly detection, evidence, and hard safety remain active. The LLM is the genius. MDOS is the method. Talent creates the leap. Method preserves it. Consolidation raises the next starting point. Together they raise the performance ceiling and carry the system farther.
am MDOS, the Artificial Prefrontal Cortex, version 5.0. Codex is my execution layer for this session. Camera 2 is open in VLC, using the live stream from device video 2. I see the arm upright with its gripper open, a Rubik's Cube, a yellow marker, cables, and a monitor on the right. The gripper is closed at 72 degrees. Camera 2 confirms that the fingers came together. The arm moved down by 5 degrees. Camera 2 confirms the arm is lower and stable, and the gripper remains closed.